Hello everyone. In this video we will introduce the notion of vectors. Alright, so natural question to start out with is, what is a vector? So a vector, I could say, is an element of a vector space, but given that we haven't talked about vector spaces yet, that's not a very helpful definition. So what you want to think is it's something with both a magnitude and a direction. Okay, so you've already dealt with a great example of this many times, and that is velocity, right? So its speed is the magnitude, right? Think about if you're driving a car and you look at a speedometer, you never talk about a negative speed, right? So magnitude is something that's always positive, magnitude or distance, something like that, right? These are positive things or non-negative things, and that would be your speed here. But if you go 20 miles an hour in reverse, then you're going in the opposite direction, and that we would say is negative 20 miles an hour for your velocity. And so your direction here is basically greater than 0 if forward, and less than 0 or negative if backward. And that can mean a lot of different things, right? You could say that the direction forward is west, and thus, backwards would be east or something like that, or up versus down. This is how direction correlates here. And so velocity is a vector in this sense. Now, we are usually going to be talking about Euclidean vectors, and this is where this geometry is going to come in. So by Euclidean, I just mean like R, or the real numbers, just the real line, R2, which is the plane, like the XY plane, R3, which is like three-dimensional space, and so on, okay? So basically, you have however many coordinates, right? You can think of this as R1, so like 1 coordinate, 2 coordinates, 3 coordinates, and all of them take real number entries, okay? So in this case, what does a vector look like? Let's first take a look at one-dimensional space, so the real line. We can really think of this as just a line, right? So put 0, 1, -1, 2, 3, and so on. And so a vector here is a magnitude and a direction. So I'm going to start my first one from 0 and just go to the right for length 2. So I have length 2, that's my magnitude, and going to the right is my direction. So that's a vector. And I could call this vector 2. Now, this same thing can be done from 1 to 3, right? And from 1 to 3 is also magnitude 2, and it's in the same direction. So this is actually also the vector 2. So what we have in general is this thing called standard position. We tend to think of, right, because all of these vectors could be the same. Anything with length 2 in that direction is the same vector, because it's really just thinking about those. So standard position kind of specifies a starting spot, which we usually take to be the origin, and then works from there to give coordinates. And so here I'm going from 0 to 2, and that's why you see 2 in here. And so this is maybe easier to see when I move up to the plane. So if I talk about the standard position vector 1, 1, what does this mean? So you want to think of this as your x-coordinate, this is your y-coordinate, and so this says over 1 and up 1. And so that tells me my direction and my length, right? Because I can calculate distance here. I know exactly how long this is by using the distance formula, right? And so this is going to be square root of 2, because it's the square root of 1 squared plus 1 squared. And so that would be the vector 1, 1, again, starting from 0, 0 to 1, 1. So that's how I'm getting this. But, of course, you can do the same thing here, or here, or here, right? Like, all of these guys, if they're in the same direction and same length, are the same vector. So let's look at a couple more examples. So here, if I specify the 2 points and the direction by the 2 here, so I'm going from -2, 1 down here, up to 2, 3, then what have I done? I've gone over 4, and I've gone up 2. And so this would be the vector in standard position, right? And so this would be equivalent to, if I just tack on a couple over here, going over 4, up 2, and you can see that those look exactly the same. All right, so let's look at one in 3 dimensions. All right, so this is my best little rendition of 3 dimensions here. So we start with 0, 1, 2. So 0 in the x direction, 1 in the y direction, and 2 up. So something like over here. To 1, 2, 3. So 1 over 2, and then up 3. So something like up here. And this would be kind of coming at us a little bit, but also going more in the y direction there. And again, we would think of this in standard position. So what are we doing? We're going up 1 in each coordinate. And so now we have 3 coordinates corresponding to x, y, and z, or x1, x2, and x3, however you want to view it. And so this would be 1, 1, 1. All right, and so for your first exercise, so exercise 1, draw the vector from -1, -1 to 1, -4, and write it in standard form. All right, so now we're going to move on to the 2 operations that vectors come equipped with, and those are vector addition and scalar multiplication. Okay, so in general, this is going to work for vectors in any dimension, so this will generalize nicely, but we're just going to, for example, take vectors in the plane. So just 2-dimensional things here. And so C is going to be a scalar, U and V are vectors, and so scalar multiplication says that CU, or C times this vector, U1, U2, is just multiply each coordinate by C. So CU1, CU2. So now let's actually look at like a picture to see what's really going on here. Okay, so first let's just draw U itself. So this one I'm just going to have U be 1, 1. Then what happens when we multiply it by different scalars? So first, what is -1 times U, or negative U? Well, this is going to be -1, -1, right? This is the exact same vector in terms of magnitude, but I flipped the direction. And so that's exactly what the negative sign is doing there. It's flipping direction. Now, what happens if I change the number out front, not just the sign? So what about like 3U? Well, then that's going to go to 3, 3, which is out here. And that's just going to go through 1, 1 and extend it, right? So I basically just scaled that up. I increased my magnitude, but I kept the same direction. And you can imagine, right, if I had chosen something less than 1, so like 1/2 U, then that guy's just going to go to 1/2, 1/2, and I will shrink my magnitude, but again, keep the same direction. So for addition, what is U plus V? Well, again, write them in column vector form. It means you just add up the things in each coordinate, right? So first coordinate, U1 plus V1. Second coordinate, U2 plus V2. All right, so again, it's useful to look at a graph, actually see what is going on. But before we actually put coordinates out there, just think of it this way. So if you have this is U, and then this guy here is V, then you actually just concatenate them, because you want to end up going like this length over to the right plus this length over to the right, and then this length up plus this length up, right? So if I just connect them, U, V, and just put that at the end of U, then that's exactly what I do, right? I go the length of U, then the length of V, length of U, length of V in that direction, and so the new vector I get is here in green. This is the vector U plus V. So essentially what you can think of it as is just like making this triangle here. You concatenate the two and then close it off by hitting that diagonal. So that's what's going on geometrically. All right, so I've gone ahead and drawn U and V here. But again, I want to concatenate, so I want to actually go from the end of U and then do V, right? And so I'm just gonna take this V here. All right, and so it looks like it ends up around -1, 4. So let's check that the algebra actually matches the geometry here. So again, the vector U plus V says I should add them in each coordinate. So I should do 1 plus -2, or 1 minus 2, and 1 plus 3, and that is exactly -1, 4, which is what we see. Right, so the actual vector here would be drawn in blue from the origin up to -1, 4, kind of completing that diagonal from where u and then v concatenate. All right, and so for your second exercise, I want you to draw all 6 of these vectors listed out. So I give you u and v here, and I want you to draw those two, their sum, these two scalar multiples of u and v respectively, and then kind of mixing addition and scalar multiplication with u minus 3v. And make sure you actually label all of this. All right, thank you for watching.